Hello, and welcome to Unit 2. This is the first lesson called Log Logic. So remember back in Unit 1, I think it was Lesson 5, we were tracking the tortoise, and we first got introduced to this logarithm idea. So it's a function where if you put in 3 and you get out 8, because it's 2 to the third power. The log is a kind of function where if you put in 8, you'll get out 3. And one thing to notice there is that the logarithm has its own base. Right there, that 2 is called the base of the logarithm. And it matches the base of the exponential form. So right over here, this is the exponential form. 2 to the third equals 8. This is the logarithmic form of that same expression. And we can convert between them using a little 3-step process. Number 1, the base of the logarithm is equal to the base of the exponential. Number 2, the logarithm equals the exponent. 3 is the exponent, and there it is. 3 is the exponent. And the third thing is called the argument of the log. That's the input value. 8. And that's the result of the exponential. There is probably a button on your calculator that says log. That logarithm is base 10. That means it's telling us the power of 10. Here's some whole number examples. 10 is 10 to the 1. 100 is 10 to the 2. 1,000 is 10 to the 3. 3 to what power is 3? And that's 1, because 3 to the 1 is 3. 3 to part B. 3 to what power is 9? 3 to the second power is 9, because 3 to the second is 9. 3 to what power is 1/3? Well, that's a -1, because 3 to the -1 equals 1/3. And 3 to what power is 1? That's 0, because 3 to the 0 is 1. And finally, if you combine B and C together, 3 to the power of -2 is 1/9, because 3 to the -2 is 1/9. Then you can place those on the number line. I would recommend just the letter. What did this pattern just show you? Noticing that the logarithm equals the exponent. Okay, let's go on to number 2. 3 to what power is 81? 4, because 3 to the 4 is 81. 10 to what power is 100? That would be 2, because 10 to the 2 is 100. 8 to what power is 8? 1, because 8 to the 1 is 8. 5 to what power is 25? 2, because 5 squared is 25. And 2 to what power is 32? So really, what you need to do, you need to start memorizing powers of 2. It's going to help you a lot. It's 5. 2 to the 5th is 32. And we can put those on the number line. I'm not going to do that because I think it's pretty obvious for this one. But my conjecture, when the argument is a power of the base, answers are whole numbers. 7 to the 1 is 7, because 7 to the 1 is 7. 9 to the, I don't mean 9. 9 to the 1 is 9. And 11 to the 0 is 1. and 10 to the 0 is 1. All right, and you can just stack those on the number line however you'd like. Now for number 4, all the answers are negative. 2 to the second is 4, so just make it negative 2. And then 2 to the negative 2 is a quarter. That's not too bad, right? 10 to what power is 1/1000th? That would be 3, but it's a fraction, so negative 3. 10 to the negative 3 is 1/1000th. 5 to the third is 125. So this is negative 3 again, because 5 to the negative 3 is 1/125th. And finally, 6 to the negative 1, because 6 to the negative 1 equals 1/6. So 3 of these 4 are going to be pretty easy, and one of them is going to be tricky. So 4 to the second is 16. 2 to the fourth is 16. So that doesn't work. Let's skip it for now. Let's come back after D. 16 to what power is 16? That's 1. Because 16 to the 1 is 16. So what's going on with C? Well, they really just want you to know it's between two numbers. So you could say 8 to the 1 is 8. 8 to the 2 is 64. So 8 to what power is 16? Has to be somewhere between 1 and 2. If you put that on a number line, okay, it's going to start with D at number 1. Then somewhere in between, it's going to be C. I guess I should label them, right? And then, let's see, then it's going to be A. And then it's going to be, at 4, it's going to be B. If the arguments are equal, then the smaller base has the larger value. It's got to be between 2 and 3. So 2 to the second is 4, and 2 to the third is 8, and 5 is between 4 and 8, so the power must be between 2 and 3. It's got to be between 1 and 2. 5 to the 1 is 5, 5 to the second, 25. Exactly 0. I don't know, because 6 to the 0 is 1. 5 to what power is 5? That's a 1. That's a piece of cake. We already did that before. And 10 to what power is 5? That's between 0 and 1, because 10 to the 0 is 1, and 10 to the 1 is 10, and 5 is between 1 and 10. You can use estimation to guess the value. Okay, 10 to the what power is 50? That's between 1 and 2. 10 to the 1 and 10 to the 2. And then 150, that's between 2 and 3, because that's 10 squared is 100, and 10 cubed is 1,000. And then 1,000, that's between 3 and 4, because 10 to the third is 1,000. 10 to what power is 500? Well, it's got to be bigger than 2, and it's got to be smaller than 3, but it's got to be also bigger than log 150. And here what they want you to conjecture or guess, educated guess, if again the bases are the same. This is a really important one. 3 to what power is 3 squared? Well, that's 2. 5 to what power is 5 to the negative 2? Well, it's negative 2. The answer is the power, because the base matches the base. This is 0, this is negative 1, this is 3, and the reason is simply by definition. The argument is b to the p, the log base b of b to the p is just going to be b. We're going to get that number back. In other words, we're going to undo it. It's an inverse. The value of log base b of x is positive. Sometimes true. Logarithms can have both positive, negative, and zero values because all these type of values can be used as exponents in exponential functions. The argument really can't be negative. So this is never true. Yeah, always true. Because that says b to the 0 equals 1. And remember, we really just have to watch out for 0 to the 0. And it already said, no, b's got to be greater than 0. So with that added in, we can say always. How about log base b of b equals 1 for any b greater than 0? I'd say that's true as well. That's always true because b to the 1 is just b. Okay, we saw that many times. In fact, 3 was all about 2 of x is less than log base 3 of x for any value of x. It's true sometimes, but what if you had 1? Then they would both be equal to 0. So that right there is a sometimes. And then finally, log base b of b to the n equals n for any b greater than 0. Hey, that's what we just did. It means it's always true. Definitions are always true. B to the log base b of n, I think they're inverses. They're going to undo each other. But again, we have to have b greater than 0. So it has to be positive, n value, b greater than 0. And then we're good to go. So you got lots of takeaways here. That'll be it for now. We'll see you next time.